All right, in our last videos, we've talked about plotting points, graphing lines, rising lines, falling lines, x-intercepts, y-intercepts. The last concept we need to leave here with for the semester is the idea of slope, and it also has to do with points and lines. So first, let's define the concept of slope. It is defined as the change in y over the change in x. So if we're talking about x's and y's, we're talking about our standard Cartesian coordinate system with the horizontal axis being called x and the vertical axis being called y. And if things are going to change for x and y, then we have to have at least 2 points. So right now we're just going to randomly take 2 points that I've already plotted, and we're going to talk about how you calculate the slope in between those 2 points. The big deal with slope is when we talk about these points, we read graphs from left to right. So if I want to look at the slope between these 2 points, and I'm not going to label the points yet, I'm just going to say I have these 2 points, I don't care for a minute what they actually are, then I start at this leftmost point and I count how I get to the next point in terms of x's and y's. And it doesn't matter whether I go horizontal and then up or up and then across. And we'll see how that works in just a second. So if I start here and say, how do I move to get to that next point? Well, it's 1, 2, 3, 4, 5 steps to the right and 1, 2, 3 steps up. So looking at how slope is defined, however much y changed, the up or down, is the top number. So that's 3. I went up 3. And my change in x is the bottom number. So the slope between those 2 points is 3/5 or 3 over 5. Notice if I go up first, I'm still going 3 up and 1, 2, 3, 4, 5 to the right. So the up number, the y value, is still 3 and the across number is still 5. It doesn't matter whether I move up and down first or across first. Right now we're just going to stop and say, okay, that's the slope between those 2 points. So let's take a look at these points. I have to move from the left to the right. So 1, 2, 3, 4, 5, 6, 7 spaces to the right. And now 1, 2, 3, 4, 5 down. So that's a -5. And when I write the slope between those 2 points, it's defined as, and we're going to abbreviate something here. The mathematical abbreviation for change is a small triangle, delta. And so this means slope is how the y changed over how the x changed. So my y's went down 5 and right 7. So this slope is -5 over 7. Notice if I had gone 1, 2, 3, 4, 5 down and 1, 2, 3, 4, 5, 6, 7 to the right, I would still have had the same slope. Doesn't matter whether I do the x first or the y first, but when I write it, the change in y goes on top. That's the definition of slope. So pause the video, look at these 2 points, and calculate the slope between those 2 points. Change in y over change in x. So 1, 2, 3, 4, 5, 6, 7 to the right, and 1, 2, 3, 4 up. So the slope here would be 4/7. 2, 3, 4, 5, 6. Yep. Okay. Try the slope between those 2 points. Change in y over change in x. So 1, 2, 3 to the right, and 1, 2, 3 down. So when I first wrote this, I would have -3 over 3. And there are reasons that I might want to still think about this as a fraction. We're going to see that in a minute. But even at that, I would want my fraction in lowest terms. So I might want to reduce -3 over 3 to -1 over 1. Or I might want to reduce it all the way down to that single integer of -1. Those 3 all tell me the same thing. Well, we could stand around and just randomly plot points all day long and calculate the slope in between 2 points, but that's not what slope is really helpful and good for. What we will find, and what you will particularly find in college algebra that slope is good for, is helping us to graph lines without having to do what you had to do in the last video, which is take an equation for a line, set up this XY table, and pick an X and calculate a Y, or pick a value for Y and calculate a value for X. Let's look at how that works as a process using slope, and then we'll talk about writing equations with this. So let's say, and again, here's my x-axis, here's my y-axis. Let's say that we were told to start at the point 0, 1. So nowhere left or right, 1 up on the y-axis. And we are told we have a slope of 2. And this gets back to that last problem. Remember that slope is supposed to tell me how 2 things are changing. It's supposed to tell me how y is changing, but it's also supposed to tell me how x is changing. Which means if somebody gives me a slope not written as a fraction, I want to write it as a fraction. And I can always write a number as itself over 1. 2 can always be written as 2 over 1. So that's now my slope. And it says, okay, from this point that you know, how do you get to the next point? Well, y changes by +2. So that tells me to go up 2. X is +1. So it tells me to go right 1. And I can do this all day long. I'm going to go 1, 2 up and right 1. And that's going to be another point. And then I'm going to go up 2 and right 1. And that'll be another point. Or I can say, I'm going to go right 1 and up 2. So right 1 and up 2, right 1 and up 2, and so on and so forth. And what we notice is from wherever we started, as long as we keep following that same slope, all of those points line up with each other. And now I've got a line. Also remember from the last video that if we were going to categorize this, this would be what we know as a rising line. Okay? And I could now label those points. Okay? I started at 0, 1, and to get to all the rest of them, I went up 2. So my y changed by 2. Okay? So I was at 1, I went up 2, now I'm at 3. I went up 2, now I'm at 5. Up 2, now I'm at 7. Up 2, now I'm at 9. Bottom number says, how are the x's changing? 1 to the right every time. So I started at an x of 0, and I went 1 to the right, now I'm at 1. Another one to the right, now I'm at 2. Another one to the right, now I'm at 3. Another one to the right, now I'm at 4. And so the points on my line are the 0, 1 I started with, 1, 3, 2, 5, 3, 7, 4, 9. Y's are all changing by 2, 1, 3, 5, 7, 9. X's are all changing by 1, 0, 1, 2, 3, 4. So if you give me a starting point and a slope, I can draw a line for you. I can start at the starting point and I can follow the slope and get more points. So let's say we start at 0, 3 and we have a slope of 1/2. So I start at 0, 3, nowhere left or right, 3 up on the y-axis. Here's x, here's y. Slope is change in y over change in x. This is a positive 1/2. So that 1 says I'm going to go up 1 and 2 to the right. Okay? So from my starting spot, up 1, 2 to the right, there's another point. Up 1, 2 to the right, there's another point. Or 2 to the right, up 1, there's another point. 2 to the right, up 1, there's another point. And I can keep doing this all. Remember, my lines don't stop. They keep going forever. So if I wanted to draw the line here, I would extend the line out past just this little set of points. And now I say, well, what are these points that I found here? Well, I follow the instructions about how I got there. I started at 0, 3, so my y was 3, and I go up 1 every time. So 4, 5, 6, 7. I started at 0 on the x, and I'm going 2 to the right every time. So 0, 2, 4, 6, 8. Okay. And again, I notice in this example, I have a rising line. Okay. Well, now let's look at this guy. Suppose we start at 0, 4. And now the slope is negative 3, or if I write it as a fraction, negative 3 over 1. Top number tells me how y changes, and this is negative, so I'm going to go down 3 and right 1. So 1, 2, 3 down, 1 to the right, new point. 1, 2, 3 down, 1 to the right, new point. Or 1 to the right, 1, 2, 3 down, new point, all of those line up, and there would be a line. And I notice that this time I have what we know as a falling line. So how about you try this one? Start where you're supposed to start, follow the slope, graph the line. Okay. So you started at 0, -2. Top number change in y, so I'm going to go down 1 and right 3. So down 1, 3 to the right, plot a point. Down 1, 3 to the right, plot a point. 3 to the right, down 1, plot a point. There's my line. If I want to label these points, I started at 0, -2. So my y is -2, and I'm going to go down 1. So that puts me at -3, -4, -5. And I go 3 to the right, and I started at 0 on the x. So 3, 6, 9. Back over here, we didn't label our points. Let's go ahead and do that. I started at 4 on the y-axis, and I keep going down 3. So I start at 4, and I go down 3, I'm at 1. At 1 and go down 3, I'm at -2. At -2 and I go down 3, I'm at -5. I started at 0 on the x's, and I keep going 1 to the right. So 0, 1, 2, 3, and so on and so forth. Okay. So if you give me a starting point and a slope, I can plot points and graph a line for you. That's the big deal in college algebra. Okay. When they say, how do you graph a line, you're going to put it in what is going to be known as slope-intercept form for your line. And that format takes whatever the equation of the line looks like and solves for the y. And then there is a number in front of the x. That number will be your slope. There is a number on the end, and that number will tell you something about your y-intercept. Okay. So let's go back and look at these lines that we've been graphing here. And I'm going to show you the equation that I started with for these lines. And how that got me this information that we use to plot the points. Okay. This is slope-intercept form because the y variable with a 1 in front of it is all by itself. In this format, the number in front of the x is my slope. That's the slope I gave you up here, and we thought about it as a fraction. This number tells me where on the y-axis I'm going to start my line, and if I'm on the y-axis, if y is going to be 1, x has to be 0. So this is y equals mx plus b form. M, the number in front of my x, is the slope. And 0 and whatever this b guy is my y-intercept. Okay. Notice when the slope is a positive number, I'm going up and to the right, up and to the right, up and to the right, and I get a rising line. In this next example, the slope was positive 1/2, up and to the right, up and to the right, up and to the right. I got a rising line. And here's the equation that I started with to get this particular graph. And that was, let me see here. X, oops, I don't want to do this in red. X minus 2y is equal to 3. Notice that is not in the form with the y by itself. So I have to move some things around. Okay. First thing I'm going to do is move the x to the other side of the equal sign because I'm going to want the y by itself. So I'm going to subtract an x from both sides. It's not a like term. I can't do anything with it over there. But now I have negative 2y, and I'm going to write the x first because I'm looking for the format y is equal to something times x plus or minus a number here. Okay? And then to get the y by itself, I'm going to divide everybody in this problem by 2. Negative 2. Oops. And that tells me I had my original problem wrong up here. This was a negative 6. I started with x minus 2y is equal to negative 6. And now I'm going to go through and divide everybody by negative 2. Negative 2 divided by negative 2, that leaves me a 1 in front of the y, and the y is all by itself. Negative divided by negative here with the x is positive, and I have to remember that if I don't see a number in front of a variable, there's an understood 1 there. So negative 1 over negative 2 is 1/2 x, and negative 6 divided by negative 2 is positive 3. That's where I got my start with a slope of 1/2 and a y-intercept at 0, 3. And notice, if we take any of these points, and I'm going to go back to the original form of this equation that I had, if we take any of these points that we got using the slope, and I plug them into this original equation, they will work in the equation. They are points on the line. I've got 6 minus 12, and that is negative 6. Okay. If I use the point 2, 4, so I let x be 2 and y be 4. Then I have 2 minus 8, and that's also negative 6. So any of the points I create using this slope and this y-intercept will work in my original equation. For this problem, the equation that I started with was, let me think, hang on just a minute. I'm going to pause my, I don't want to run out more time here. The equation I started with here was 3x plus y is equal to 4. And I said I want to solve for the y. Okay, so I'm going to subtract 3x from both sides. And that's going to give me y is equal to negative 3x plus 4. Y's all by itself. That's the number that tells me about the slope. And I started you off here with a negative 3. And I said, let's start with a y-intercept at 0, 4. So that's where I got it from that equation. Here, I started with x plus 3y is equal to negative 6. And I said, I don't have the y by itself, so I'm going to subtract an x from both sides. So now I've got 3y is equal to negative x. There's an understood 1 in front of that x. And then I divided everybody by 3 to get a 1 in front of the y. So y is equal to negative 1/3 x minus 2. Slope of negative 1/3. That's what I started you off with. Y-intercept at 0, negative 2. So how about you take the equation (3x plus 2y is equal to 8). And first thing, get the y by itself. Okay. Solve for y. Okay. All right, so you pause the video. We would have subtracted 3x from both sides. So now we've got 2y is equal to negative 3x plus 8. And then we would have divided everybody in the problem by 2. So that I have y is equal to negative 3 over 2x plus 4. Okay. Now, pause the video and be prepared to tell me in a minute what's the slope for this guy and where is my y-intercept, and am I going to get a rising line or a falling line? Okay. So the number in front of the x is my slope, negative 3 over 2. My y-intercept is 0, whatever that number on the end is. And since my slope is negative here, I should get a falling line. Now, use that slope information and that y-intercept to plot the y-intercept and 3 more points that are on that line. Connect up the dots and show me what your graph looks like. All right, so we're going to start at 0, 4. The slope, and I'm about to get cut off on this video. So I'm going to stop this here. And I'm going to come back and do a short video to finish this problem.